So this is the part of our storage module where we begin to talk about the technologies that we can use to connect to storage that we can form data stores from. Okay? These next two lessons, fiber channel storage and iSCSI storage, are all about how we can create data stores from LUNs derived from block level storage. So why don't we dive right in here and have a look at fiber channel storage. We'll look at the uses of fiber channel with ESXi and look at the different components of a fiber channel architecture. So that is, we'll have a little mini primer on fiber channel storage networking or fiber channel storage area networks. Then we'll have a look at how we configure it with ESXi, which there's not a whole lot to do actually. Fiber channel and ESXi play so nicely together. There's not a whole lot of configuration that needs to be done. And then we'll dive a little deeper and look at how multipathing actually works with fiber channel. That is, how can we create and ensure that there are multiple paths, multiple network paths from your ESXi host to your fiber channel LUNs. So fiber channel stores virtual machines remotely on a fiber channel SAN. So you can tell by this picture that what we have are our ESXi hosts running virtual machines, and those virtual machines are commonly stored on a fiber channel storage array on LUNs creating, or logical unit numbers, so groups of disks formed to create a logical volume, is where we'll put our virtual machine files. You'll notice that our ESXi hosts internally have something called a fiber channel host bus adapter. So that is a hardware component, usually fits in a PCI slot, where we will then connect that host bus adapter using a fiber cable to what we call a fiber channel switch. Okay, so this little cloud here, this little SAN, represents a series, at least two, to avoid single points of failure, fiber channel switches. The storage arrays themselves are also connected to the same fiber channel switch, and therefore all of our hosts can see all of that storage. Now, this is a nice, highly performant infrastructure. We support within ESXi up to 32 gigabit fiber channel host bus adapters, and we also support fiber channel over Ethernet, or FCOE, which allows us to not only use to essentially use a single box for both fiber channel traffic as well as Ethernet traffic. So you'll see this picture similarly in many of the lessons to come, where we have an external storage array up at the top. So that's where we'll start. And we'll have ESXi hosts, each with their host bus adapters. Here we show two of them, once again to avoid single points of failure and to allow for multipathing to improve reliability and performance within the ESXi hosts. Here we're showing two fiber channel switches, each ESXi host and HBA connected to one of two fiber channel switches. Now, once we hit the storage array itself, we have what we call a storage processor. Think of that as like a computer on your storage array that allows for the interface, or the storage area network interface, between the storage area network and the array itself. And then once you hit the storage array, we have LUNs. And these LUNs are created from groups of capacity devices. Okay? So these devices can obviously be physical hard disks, they can be solid state devices, they can now even be NVMe devices that we can directly connect to. So these are the different components that we have. You'll notice here that what we would typically do is create out of this group of disks some sort of redundancy in a RAID format, be it RAID 1 where we have mirroring, RAID 10 where we have striping and mirroring, RAID 5 or 6 where we add parity to the mix. Lots of different ways for us to ensure redundancy within the storage arrays themselves so that the disks themselves, or the storage devices, don't themselves become single points of failure. Now, when it comes to addressing the components of a storage area network, we have a little bit different of a format. We know that in an Ethernet TCP/IP infrastructure, we'll use IP addresses to address or to name or to identify each of the different endpoints. Well, in a storage area network, in a fiber channel storage area network, we use something called a worldwide name. It might seem similar to what a MAC address might look like. This is a unique 64-bit address that is assigned to each node within the storage area network itself. So the storage processor or storage processors will have their own unique worldwide name. The HBAs in each ESXi host themselves also have their own worldwide name. And so, I'll go back. And so if you connect your HBA to the fiber channel switch, and you've set up zoning properly, which is done at the fiber channel switch level to allow us to segment the fabric, kind of like a subnet would be in an IP. And you set up what we call LUN masking, which is done typically at the storage array, but can also be done at the ESXi host level, but most typically at the storage array level. That ensures that, or I should rather say not ensures, but allows for particular HBAs and their worldwide names to access particular LUNs. So it's a little bit of access control is what LUN masking allows us to do, okay? Making sure that each ESXi host has the same set of presentation of LUNs so that every ESXi host can see the same data stores, right? So we use worldwide names. Now, when it comes to multipathing with fiber channel, there are a number of ways to do this. But of course, the most important thing that we can do here is avoid single points of failure and provide multiple ways from each ESXi host to hit your storage array, even in the event of any single component failing. So you'll notice that starting at the bottom here, we have 2 HBAs in each ESXi host, and each of these HBAs in the hosts are connected to a separate storage area network switch, or SAN switch, fiber channel switch. So HBA1 is connected to switch A, and HBA2 is connected to switch B, and the same thing goes to each host. You'll have multiple storage processors on your storage array, and each of those storage processors will also be connected to each switch, each fiber channel switch. And this allows us not only to do sort of active-passive failover scenarios, but also active-active load balancing scenarios. Now, when it comes to fiber channel over Ethernet adapters, there's a little bit more involved. Instead of an HBA on your ESXi host, what we have is something called a converged network adapter. When we say converged, it literally takes on a single PCI card a fiber channel HBA chip as well as an Ethernet chip and brings them together over a single interface, okay? Using a single cable from your ESXi hosts connected to a fiber channel over Ethernet switch. What ESXi sees when you plug a converged network adapter or even a software-based fiber channel over Ethernet adapter using a standard NIC that happens to have fiber channel over Ethernet support, what ESXi will see are literally 2 different devices. If you go to the storage adapter section in ESXi, you're going to see an HBA. If you go to the Ethernet or if you go to the network adapter section, you're going to see an Ethernet adapter. Even though they're plugged into the same or housed on the same PCI card, you're going to see 2 separate devices, and you will configure them as if they were 2 separate devices. But what fiber channel over Ethernet allows for then is far less physical infrastructure that you have to manage. Rather than a separate fiber channel switch and a separate Ethernet switch, you simply have 1 device. Of course, when I say 1 device, I'm not considering the fact that we need to avoid single points of failure. So of course, there's going to be 2 converged network adapters and 2 fiber channel switch, FCOE switches, and so on each ESXi host and in your racks. Now, when it comes to configuring hardware-based fiber channel over Ethernet, you simply plug it into your ESXi host. There's typically a driver that needs to be loaded. That'll come from the vendor of the converged network adapter itself, and so you'll load that into ESXi, and ESXi will simply discover the HBA and see what's connected to it and present you with a set of LUNs. But if you have one of those NICs, just a standard Ethernet NIC that happens to have fiber channel over Ethernet support, then there's a little more that you need to do. What you need to do is configure a VM kernel port. And when you build a VM kernel port on your ESXi host, you will bind that VM kernel port to a software-based fiber channel over Ethernet controller. What this does is it creates literally a virtual FCOE controller in your ESXi host that is then connected with software to that NIC with FCOE support. By doing this, you'll then be able to see the LUNs on the other side when you hit a button that says scan or rescan your storage area network. ESXi supports VLANs for this because it is a standard VM kernel port, so you can do VLANs. And we can put up to 4 network adapters that support fiber channel over Ethernet in every ESXi host. So you'll notice what I've done here is I've clicked on my ESXi host, and I'll go to Configure under Storage Adapters. And I'm going to hit Add Software Adapter. Now, when I do this, there are 3 different options that we have. We have the ability to add an iSCSI software adapter. We'll look at that in the next lesson. We have the ability to add an NVMe adapter with RDMA support. This allows for us to connect our ESXi hosts to NVMe devices over a SAN fabric. Okay? So rather than connecting to a LUN, we're actually going to connect to an NVMe device. Okay? And finally, we have a software fiber channel over Ethernet adapter. And if I'm using software FCOE, this is what I'll choose. So I'll select the physical adapter that I want to bind this VM kernel port to, and I will then choose the VLAN ID and a priority class and the controller MAC address, which will be pre-configured for you based on the physical NIC that you have bound to that VM kernel port that you had created. A very simple 2 steps to do. So really, it's a simple exercise of connecting that HBA to the fiber channel switch. That fiber channel switch is connected to your storage area network, or sorry, is connected to your storage array. The LUN masking is set up such that your storage array is allowing your ESXi host and its HBAs via their worldwide name to connect to that LUN. Then you hit this button that says rescan adapter, and voila, you see the LUNs. And from there, we will be able to create data stores, okay? And we'll get to that part of it as soon as we finish the next lesson on iSCSI for ESXi. And so that's coming right up. Talk to you soon. iSCSI storage infrastructure is another great way for us to utilize shared storage in an efficient sort of manner. Okay, so let's have a look here in lesson 3 at iSCSI. Now, what iSCSI really does is it takes the same SCSI commands that I was using to connect from my ESXi host to my LUNs via a fiber channel network, and it takes those same SCSI commands and it wraps them in an Ethernet frame. The nice part about that is that we can utilize the same sort of technologies without having to build a separate fiber channel SAN network. So we do the whole thing over Ethernet. Okay? Just like Ethernet, just like fiber channel, we are accessing block level storage. So let's have a deeper look at IP-based storage with ESXi. We'll look at the iSCSI components and addressing in a similar way that we did to the fiber channel side. We'll look at iSCSI initiators and iSCSI targets, and then we'll look at some of the naming conventions that we have beyond simple TCP/IP, which we absolutely will use in IP-based storage and iSCSI, but we'll look at some specific iSCSI naming conventions that we have. So notice that this picture that we have here in the iSCSI lesson is very similar to the picture that we had in the fiber channel lesson. We have our ESXi hosts on the bottom, and we have our storage arrays at the top. Except now, we have a couple of different types of iSCSI initiators. So this is a new term. In the iSCSI world, rather than having client and server being kind of the term of art, we have initiator and target being our term of art. Initiator is the source of the iSCSI, is the system that's sending iSCSI commands to the target, which is the actual storage array, okay, which is where the LUNs are found. So in our cases, ESXi is going to be the iSCSI initiator, and the iSCSI target will be had at the storage array. And right behind those iSCSI targets, we're going to see our LUNs. So here we have two different types of iSCSI initiators. We have standard Ethernet adapters, and we have something called a dependent hardware SCSI initiator. Okay, and those are considered software-based iSCSI systems. And then we have our full hardware iSCSI systems, and those are called independent hardware iSCSI initiators. I got the terms right there. Okay. Next, we have our Ethernet network. So here's our Ethernet switches. And on our storage arrays, we have our storage processors. And this is where our iSCSI targets are actually found. Now, all of this addressing can be done very nice and easily with TCP/IP and DNS, fully qualified domain names, and the whole bit. And of course, right behind our storage processors on our storage array, we'll have our LUNs that are created from our capacity devices that are set up in some sort of redundant format with whatever RAID levels are supported on your storage array itself. So iSCSI addressing, like I said, can be done via IP address, but it's also done in a couple of other ways. We, of course, have our iSCSI initiators and our iSCSI targets. And one way that we can identify an iSCSI initiator or target is through its IQN, or iSCSI qualified name. It looks like a DNS name, but it's reversed. Okay? So we'll look at it like this. You have IQN at the beginning, and then you have something that represents the vendor of your iSCSI target or initiator. Okay? So in this case, you're going to have the year and the month that the iSCSI qualified domain was registered, then the top level domain name and the domain name. So it's a little bit reversed from our standard DNS fully qualified domain names, right? And we include the year and the month here. So up here at the target, it'll be the vendor like, Dell or NetApp, whoever it might be that built your iSCSI storage array, okay? And then down here at the bottom, you'll have your iSCSI initiator vendor, which would be, if it's software-based, it's going to be VMware, and if it's hardware-based, it's going to be whoever the chipset is from on your PCI network device, be it Intel or Broadcom or QLogic or whoever it is that builds these. Okay? You're also going to have, at the end of this iSCSI qualified name, an alias and then a unique identifier for each of the IQNs. Now, the alias is something that we will type in when we create the iSCSI target on the storage array, or we create the iSCSI initiator on the ESXi side. And then the alias is going to be unique to each physical port, right? Whether it's a storage processor here or whether it's an HBA, okay? There's an alternative to IQN, and that's called EUI. And it's called Extended Unique Identifier. And it's very similar, where we'll have a unique address for that represents the vendor, and then a unique address for the endpoint, be it the storage processor on the iSCSI target side or the Ethernet adapter on the iSCSI initiator side. We're going to have a look at using these in the upcoming lab. So if it's a little bit confusing now, wait till you just dive into the client, and it'll be really clear when you get to that point. So when it comes to the naming conventions here, we're not going to be using worldwide names like we would on the Fibre channel side. We're going to be using a couple of different naming conventions that help us to identify each unique endpoint, okay? Each unique LUN, for that matter, or each unique target on the storage array side. One of the ways to do it is by using a runtime name. And the runtime name describes the path from ESXi all the way to the LUN. And it starts by giving an HBA number to the HBA in your ESXi host. In this case, you see it's VMHBA65 is the runtime name here, okay? And then on the ESXi side, what we have is a channel and channel number, right? So a channel 0 is your first Ethernet card. A channel 1 would be the second Ethernet port. And then on the storage array side, we have a target number representing the one of the multiple targets you'll have on each storage array. And then finally, the LUN number, okay? So the runtime name is very useful to understand that if the runtime name is unique and we have a LUN on the other side, that we can actually see the same LUN from multiple paths. Then we have, of course, the iSCSI target name, which will have, in this example, we're using a FreeNAS storage array, so you can see that here. And then its alias includes the IP address of, in this case, of the FreeNAS device, and then the LUN number behind it. So lots of different ways for us to then address this. So there are a couple of different types of iSCSI adapters that are available to us, like I've said before. Now, a standard Ethernet adapter can always be utilized as a software-based iSCSI adapter. But ESXi has a little bit of overhead to do when you're utilizing this. The only thing that we need in the host is the NIC itself, as well as a driver for the NIC. Then what we're going to do is we're going to create a VM kernel port on the ESXi host. We're going to take that and bind it to the physical adapter. Okay, so now we've got the NIC driver in ESXi set up for that physical adapter. ESXi itself handles the entire TCP/IP stack through the ESXi kernel, and then we enable the iSCSI initiator on the ESXi side itself. Now, if you have a little bit of a step-up Ethernet adapter, we call this a hardware iSCSI adapter, where we do, in addition to the NIC driver, we have a TCP/IP offload engine built into the physical adapter. So this alleviates some of the work that ESXi will have to do in order to support iSCSI. Of course, on the ESXi side, all we need is the NIC driver, and then we create a software fiber channel over Ethernet adapter and bind it to a VM kernel port, and there we've got access to this dependent hardware iSCSI adapter that's a little bit more efficient than the software adapter, where ESXi also has to manage that whole TCP/IP stack. Now, if you're using an independent hardware iSCSI initiator, this is a really nice thing because ESXi looks at this not as an Ethernet adapter, but as an HBA, a host bus adapter. So all of the work that ESXi would normally have to do is now managed by the physical controller itself. And ESXi doesn't need a VM kernel port for this. All we do is plug it in. ESXi sees the HBA, sees whatever is connected to it on the other side, discovers the LUNs, and allows you to create your data stores on those LUNs from there. Let's have a look at the network configuration when we're working with either a dependent hardware adapter or a software fiber channel over Ethernet adapter. So the first thing that we have to do, of course, is to create this VM kernel port. So I'm going to go onto my ESXi host. I'll select Configure. I'll go to Virtual Switches, and I'll hit this button that says Add Networking. I'll add the VM kernel port. I'll give it an IP address, and I'll give it a name. In this case, I've named it IP storage. And I have then bound this VM kernel port to one or more physical adapters. Of course, the more the merrier in terms of physical adapters. And we would, of course, like to have physical separation between our IP-based VM kernel ports and the rest of our storage traffic. And here we certainly have, we have two adapters, and it's done on the same switch, but we can still have physical separation when we have two ports attached to the same virtual switch. Okay? As long as the traffic doesn't compete, and if we're smart, we use VLANs if they have to. Okay? So we'll use VLANs to separate this if we have to. Once we have created our VM kernel port in the networking section, we're going to go over to the storage section and select storage adapters. Well, we'll hit this button that says Add Software Adapter, and we'll add this software iSCSI adapter. Okay? We simply click OK at this point. Okay? It will then grab the first VM kernel port that it can see and bind to that. Okay? So make sure that when you are discovering your iSCSI target, that it is on a network that is available only to the particular VM kernel port that you would like to see. So if your management port, for example, can see your iSCSI storage array, ESXi will use that management port for IP-based storage. So either use separate physical networks, okay, or use VLANs when you're configuring your IP-based storage. Now at that point, all you have to do is find your storage array through what we call iSCSI discovery. Now there are two methods for iSCSI discovery, where ESXi is going to send a command out to your storage array and say, hey, find me the LUNs. There's static discovery, which is a manual process, okay, where I will tell ESXi the exact iSCSI qualified name, alias, and unique address of each of the targets. Or I will do something called dynamic discovery. Dynamic discovery sends a command to the storage array saying, hey, storage array, tell me, ESXi, the list of all of the LUNs that you have available for me. At that point, I can simply see the list of LUNs like we see down here in this little tiny window here, and we'll be able to select those LUNs and create data stores. Now, storage traffic needs to be really efficient. And so for that reason, we don't actually do any encryption over the wire of our storage traffic. And this is an important thing to do in order for our storage traffic to operate as efficiently as quickly as possible. But we certainly want to isolate our physical networks so that somebody at their desk can't install an iSCSI initiator on a Windows machine, for example, and go and see a bunch of LUNs on your storage area network. We don't want that to happen. So we'd like to have physical separation between your ESXi hosts, the storage and the storage array, and the rest of the network that you're working with, of course. Okay? But if you can't do that, one of the things that you can do is something called CHAP, or the Challenge Handshake Authentication Protocol, which is an iSCSI format that allows for a shared secret between your ESXi hosts, your iSCSI initiators, and your storage array, your iSCSI targets. Okay? So all you're going to do is type in, when you create your iSCSI target on your storage array, give it a little secret, right? A secret passphrase. Type in that same secret passphrase on the ESXi side, on your HBA, and then that discovery process will be allowed to occur, and you'll be able to see the remote target. Okay? ESXi supports two types of CHAP. There's unidirectional, where ESXi authenticates against the storage array, and there's bidirectional, which is done in both directions, obviously. ESXi can do per target CHAP as well. So typically it's just done on the HBA, and it's a single shared passphrase for all of the targets that are remotely available. But you can, if you want, configure a per target shared secret. Now, once again, multipathing is an important thing. And we want to show you here how to do multipathing with iSCSI storage. And this is going to depend upon whether or not you're using an independent hardware adapter or you're using a software or dependent hardware adapter. When you're using a software or dependent hardware adapter, what you will do is create a single VM kernel port, and you're going to use IP hash-based load balancing to bind two physical NICs to the same VM kernel port. We learned all about how to do that in module number 5. Once that's done, of course, with IP hash-based load balancing on the physical switch, we have to create a NIC team and support Link Aggregation Control Protocol, or LACP. And then the iSCSI storage adapter will then be the iSCSI storage array will be able to be accessed across multiple physical ports. Now, of course, if you have independent hardware adapters, each of those independent hardware adapters will independently discover the remote LUNs, and then ESXi will say, oh, I've got multiple paths, and that's all there is to it. Nothing that you actually need to create. Now, when it comes to binding VM kernel ports, one of the things that you can do is, if you want, also create, rather than a single VM kernel port using IP hash-based load balancing, you can create multiple VM kernel ports. Okay, multiple VM kernel ports, each bound to a separate physical adapter, also gives you multipathing. Now, one of the things that you'll have to do after you have created the software-based HBA is head over to the port binding, network port binding link, once you've selected that HBA, and then add the additional VM kernel ports through which you will access the remote targets. Well, finally, we're going to have a look at the lab. And in this lab, we are going to create the VM kernel port, and we are then going to create a software iSCSI adapter and bind it to the VM kernel port, and that will allow us to see the remote storage array. Okay? In the lab after that, we're going to see those remote LUNs and create data stores from them. Okay? So you are now well on your way to having a place for you to store your virtual machine files. I hope you've enjoyed that. Okay? We've looked at all kinds of different ways now to manage iSCSI through the different hardware options that we have and the simple configuration that we have to do by building a VM kernel port and then binding a software adapter to that VM kernel port. So why don't we go ahead and have a look at the labs, and then when we come back, we will have a look at creating VMFS data stores in lesson number 4. We'll talk to you real soon.